In this segment, we will introduce the concept of Restcontroller. Let's talk about the introduction to Restcontroller. Restcontroller is a key component in SpringBoot applications. It is used to handle RESTful web services. Restcontroller maps HTTP requests to methods and returns the response in JSON format. It is an annotation provided by Spring. In the previous segment, we discussed the concept of Restcontroller. To create a Restcontroller in a SpringBoot application, we need to annotate our class with the @RestController annotation. This annotation combines the functionality of the @controller and @response body annotations. By using the @RestController annotation, we can achieve both controller and response body functionality in a single class. Furthermore, all the methods in the class will have their return values automatically serialized and sent back as JSON or XML responses. This makes it easier to develop RESTful APIs in a SpringBoot application. This code snippet is a simple example of creating a Restcontroller in Java using the Spring framework. Firstly, we import the necessary classes for handling HTTP requests and creating a Restcontroller. We then create a Restcontroller class with the annotation @RestController and specify the mapping for the endpoint in the @request mapping annotation. In this example, the endpoint is hello. Inside the Restcontroller class, we define a method with the annotation @getMapping, which handles GET requests to the specified endpoint. The method returns the string hello world as the response to the GET request. This code snippet is another part of the example. Here, we have a main class called Hello World application that is annotated with @SpringBoot application. This annotation enables auto-configuration and component scanning. The main method calls springApplication.run, which starts the SpringBoot application. It takes the Hello World application class as the argument, along with any command line arguments. In the previous segment, we learned how to create a Restcontroller. Now, let's take a look at how to map HTTP methods to methods in the Restcontroller. The RESTful architecture defines a set of HTTP methods for performing different operations on resources. In SpringBoot, we can easily map these HTTP methods to methods in the Restcontroller using annotations such as @getMapping, @postMapping, @putMapping, and @deleteMapping. Let's go through each of these annotations and understand their usage. In this Java code snippet, we are creating a Restcontroller class called APIController. We then define 4 methods, each mapping to a specific HTTP method using the @requestMapping annotation. The first method, getExample, is mapped to the get method. It returns a string that says, "This is a getRequest example." The second method, postExample, is mapped to the post method. It returns a string that says, "This is a postRequest example." The third method, putExample, is mapped to the put method. It returns a string that says, "This is a putRequest example." And finally, the fourth method, deleteExample, is mapped to the delete method. It returns a string that says, "This is a deleteRequest example." In the previous segment, we discussed mapping HTTP methods in the Restcontroller. Now let's dive into how to handle requests and responses in a Restcontroller. First, let me explain the key points. In the previous segment, we learned how to handle request and response in the Restcontroller. The first point is about Junit. It is a popular testing framework in Java that allows us to write unit tests for Restcontrollers. With Junit, we can validate different endpoints and verify their responses. We can also mock dependencies to isolate the Restcontroller under test. The next point is about Postman. It is an API testing tool that allows us to send HTTP requests and validate the responses. With Postman, we can easily create test cases and run them against the Restcontroller endpoints. The third point is about Mockito. It is a mocking framework in Java that allows us to mock dependencies and simulate their behavior. With Mockito, we can create mocks for external dependencies and test the Restcontroller in isolation. The fourth point is about SpringBoot test. It is a testing framework provided by SpringBoot that allows us to write integration tests for REST controllers. With SpringBoot test, we can start the application context and send HTTP requests to the REST controller endpoints for testing. The next point is about test containers. It is a Java library that provides lightweight, disposable containers for running integration tests. With test containers, we can easily spin up containers for databases, message brokers, or other dependencies and test the REST controller against them. The last point is about code coverage tools. These tools, such as Jacoco, help measure the coverage of our test cases. They allow us to identify areas of our REST controller that are not covered by tests and improve the overall test coverage. In the first snippet, we are importing the necessary classes for writing unit tests. We are using the Junit framework and the Spring Runner class for running the tests. We also import the mock MVC class, which allows us to simulate HTTP requests to our REST controller. Then, we annotate the class with @runWith, Spring Runner, class, and @WebMVCTest, REST controller, class, to indicate that these tests are for the REST controller. Finally, we auto-wire the mock MVC object so that we can use it in our tests. In the second snippet, we define a test method named test_getAllUsers. We use the mock MVC object to perform an HTTP GET request to the user's endpoint. We then use the inExpect method to verify that the response status code is 200, OK, and the content type is application, JSON. Finally, we use the JSOnPath method to verify that the name of the first user is John, and the name of the second user is Jane.